It's an opportunity then for a venture capitalist to get together with a bunch of programmers and say, let's do what Spore did, but let's start with what the guys from Noble Ape and everybody that's in Biota podcast are already coming up with.
I don't think they go far enough. See, I think I look at Noble Ape and what's there is the computer science.
Right.
Now you need, you're right, $100 million.
Welcome to Biota Live. I'm Tom Barbalet, and this is a continuation of the Biota podcast. For more information on the Biota podcast, check out biota.org/podcast. We have our first caller.
Hi there, Tom.
Hey, Gerald. Good to talk to you.
Hey.
So, as you know, we have some news and notes, and we may have more callers calling in. But I'll start by saying if folks want to call in, the call-in number is 646-200-0640. The next episode, Friday the 11th of July at 8 p.m. Pacific, new and closed to open source. This topic was discussed in the Biota conversations. Is open source good for artificial life? However, I thought with about 15 months since we last talked about it, that it may be an interesting topic to discuss about creating new open source artificial life projects or moving closed source artificial life projects into open source. I was debating initially whether we would call this the Jeffrey Ventrella intervention, but I understand that he may actually be in Canada when we'll be recording this show. More on that a little bit later. However, it's pretty critical for there to be a nice group of open source artificial life projects currently, particularly if you look at things like the Evo Grid, but also I appeared this week on Floss Weekly, and whilst the audio hasn't yet gone up, it will be released sometime this evening, I've heard. Gerald, did you have a chance to listen to the unedited version I passed out to the group?
No, I didn't quite have time, but I subscribed to Floss Weekly, so I'll get it in the feed, of course.
Terrific. Quite a long chat, quite a lot of stuff discussed. It'll be interesting to see how they edit it down. The Biota CDs, we have 1,000 CDs that will be arriving sometime in the next week in Las Vegas, and then about 400 of them will go to the UK, and bundles of 50 and 25 will go to various other places. However, if your university or institution would be interested in a pile of Biota CDs, please get in contact with me. I heard from the folks in Brighton this week that some of them are going to Artificial Life 11, so some of them will be getting the CDs through that. However, some aren't going. And I saw their displays on Facebook, and they look like an interesting group of folk who would certainly benefit from Biota CDs. But if you know a similar group of people, please get in contact with me, tom@nobleape.com. The Biota CDs contain about 16 hours worth of Biota podcast-related audio, information on how to subscribe, and also that very important bit of information that once you've done subscribing, please pass on the CDs to others. And it'd be interesting to see how many folks subscribe to the podcast based on the Biota CDs. Great news. Bruce Damer will be in London on July 11th, actually next Friday, discussing the Evo Grid and having a chat with Justin Lyon. It is, I think, possibly the third or maybe even the fourth meeting of Graytham London, and it is at the British Computer Society, 5 Southampton Street, London. Now, it's critical that folks get in contact with the British Computer Society at least 24 hours before the Graytham London meeting if they're interested in attending. The person to contact is Mandy Bayer. Her email address is mandy.bauer@ hq.bcs.org.uk, and the contact number is 01793417417. It's critical that folks in London who are interested in attending, and particularly folks coming up from Brighton or other areas in the south of the UK, that they get in contact with Mandy and let Mandy know that they're coming. Otherwise, you won't be able to get in, unfortunately. The great Silicon Valley, San Francisco videos went up, and I'd like to send a shout-out to Dick Gordon and possibly a wide variety of other folk who are listening to the podcast in Second Life currently. Ironically, well, there were a number of things through the videos. I thought they were really well done, and thanks once again to Al Lundell for putting these videos online. Through Sharon Minsook's demonstration, it occurred to me that she and Dick Gordon vend on a lot of issues, and I contacted Dick and Sharon today, and it turns out that they had been talking about 6 months prior with regards to their various artificial life interests, so it might be interesting to see some collaboration there. And similarly, Biota is part of the Contact Consortium, and there was a new group started this week in the Contact Consortium. Bruce Damer's been talking about it a little bit, but it's the Virtual Worlds Timeline Project. This is an interesting project because there is some overlapping into artificial life, but also we will probably do an artificial life timeline, or artificial life roadmap, more importantly, sometime in the near future. So the lessons learned from the Virtual Worlds roadmap will certainly be useful with regards to the artificial life roadmap as well. I appeared on Floss Weekly, and it was an interesting interview. I passed out the unedited audio to a group of folk who have appeared on Biota Live previously. But at the end of the interview, Leo Laporte and Randall Schwartz, who were the two interviewers, mentioned that they thought that the Biota community needed an infusion of $100 million in order to make what we were talking about real. And I thought that was a very interesting figure. Certainly when Bruce got to that point in the unedited interview, he had a good chuckle about it as well. Do you think $100 million is enough, Gerald?
Oh, by no means. It would take a lot more than that.
That was my thinking as well. I think $100 million each. But anyway, it was a fascinating chat. I think there was some insight that came through it, and also some greater kind of connection to the open source community. And it'll be interesting to see. They claim to have about 30,000 listeners. It could be a little bit more, it could be a little bit less. Both Gerald and I subscribe to it, so we're already active listeners to Floss Weekly. But it'll be interesting to see the overlap with regards to the open source community that listens to Floss and folks that are interested in artificial life. They are probably listening to this very podcast, Gerald, for the first time, having listened to the Floss Weekly chat. So welcome to the folks who are listening based on Floss Weekly. This is something you can actively contribute to in terms of participating in Biota Live. We also have a variety of mailing lists, both the Evo Grid, Biota Conversations, the related Grey Thumbs. Please check out the Biota site and click on the mailing list link to get more information with regards to that. For folks who are listening in currently, we have an additional person in the chat window. If you would like to participate in the chat as opposed to calling a US number, you can get to it from the Blog Talk Radio page, which you can get to from biota.org/podcast. If you would like to call the US number, the number to call is 646-200-0640. Now, Gerald, I put the call out last week with regards to a particular topic, and I got one response but no feedback in addition to that initial response. So I put the call out that a new topic should be proposed with regards to this evening's chat. What do you think we should talk about this evening?
Oh, we should talk about everything possible, anything that comes up.
Very good, very good. But you did put a specific topic out there.
Yeah, well, I wanted to, I several times I've seen the Noble Ape simulation. I've seen the cognitive simulation. And you've talked about it a bit in terms of fear and desire, but those are not the right terms for me to understand it. So if there's some way for you to explain some of it in terms of how the software works, if you even understand it.
Certainly. And there's some good background to this because I've just submitted the Nature-Inspired Informatics chapter on the cognitive simulation as well. So I'm pretty well primed for this kind of discussion. I thought it might be easiest if I just gave some background into the kind of leading towards the fear and desire concepts to see how I got to fear and desire, and then moving from fear and desire into broader simulation models.
Can I interrupt you if you're not technical enough?
Certainly.
Okay.
Well, I wanted to talk in general terms initially about how I actually came to the Noble Ape cognitive simulation, because I think that might give some background in terms of why we started with these concepts and then moving on from there. But the background to Noble Ape cognitive simulation, I started developing Noble Ape, and in the process of starting the development, I collected together a wide variety of pieces of software that I'd written up until that point. And one of those was an Agar simulation. And Agar simulation had been something I'd been tinkering with probably 3 or 4 years prior to the development of Noble Ape, mainly just as a means of doing full-screen real-time graphics. And this was something that I was doing on Hercules monitors on old XTs, but also early VGA monitors as well, as just a way of trying to improve frame rates and these kind of things. And the Agar simulations could produce kind of beautiful color effects. So the background with regards to the software was an Agar simulation, but in terms of the broader methodologies, 2 texts come to mind. The first is by David Kirsch, and it actually appeared in Margaret A. Bowden's Philosophy of Artificial Life book. David Kirsch was talking about the problems associated with concept-driven artificial intelligence models. So basically taking objects and then taking the objects out and describing the objects as autonomous components as you put them into whatever artificial intelligence model you were using. And his analysis came from Rodney Brooks' early work at MIT with regards to putting cameras on robotic ants, and how if the robotic ants had to actually work out objects through their cameras, that it created a wide variety of kind of clunky causation that slowed down the artificial intelligence gathering process associated with these robotic ant or cockroach-like creatures wandering around. So David Kirsch had generated out of that some distinction between concept-driven and concept-free artificial intelligence models. And I was fascinated by this idea of concept-free artificial intelligence, the idea that you would just have streams of information coming into your artificial intelligence model, and then you would get actuators from that, and the way the sensors interacted with the particular AI model in order to get movement and other things coming out. So that was the kind of raw component of the cognitive simulation. And I also had read a lot of Bertrand Russell, and I was fascinated by Bertrand Russell's idea of logical atomism. And logical atomism at its core is about describing sense data in atomic particles. But that initially looked like it was talking about concept-driven artificial intelligence, that these atoms were actually highly descriptive components. I thought to myself, it didn't have to be that way. These atoms could just be part of the stream. They could just be kind of distinct frames almost if it was taking in camera information, for example, into the AI model. So from this, I wanted something where information was constantly being pumped into whatever AI I had. I like the idea of concept-free as opposed to actually taking objects out. And I had this Agar simulation, which I had been developing for 3 or 4 years. And what interested me in the Agar simulation was not, and to give some background to the Agar simulation, it related to energy-rich Agar, which kind of bacterial growth, single and multi-species bacterial growth occurred in the Agar with various breeding and movement properties through the Agar, which really was tuned more for visual effect than any kind of biological modeling. But through this Agar simulation, I started seeing what I was thinking of in terms of kind of like meta-Agar, in terms of information transfer. So rather than looking just at strict population density movement, that you could look at the way this population density moved as a means of information transfer as opposed to just population densities moving over the Agar. So this got me thinking again, and I found 2 fundamental components to these population density movements, irrespective of the weightings or what have you that I put into the Agar simulation. And one of these things was a kind of spreading operator, which took a single population, a single point in the Agar, and effectively as it grew, it kind of smeared over, and this is just simple cell-cell intersection in some regard, or Agar cell intersection. And the second thing that struck me was as soon as I put any regenerative growth back in the Agar, the idea that the bacteria would feed on the dead carcasses of the previous bacteria, there was almost a wave-like motion that actually came through the Agar as the bacteria died into the Agar and then was used again as food. And this produced a different kind of operator, which was more kind of time undulating. So from these two competing equations, I launched Noble Ape with a cognitive simulation that was very similar to two-dimensional Agar. It was flat. However, rather than based on population densities that were moving through, it just had these two functions, one representing a spatial spread and the other one representing a time-changing component that kind of describes the two Agar properties that I've mentioned. And initially, I had wanted to write a document that was, in some regard, a manifesto to the Noble Ape development. And what came out of that was the original manuals, which I believe you own a copy of, Gerald.
That's true.
Whether or not you've read it is not necessarily important to the conversation. Lots of people seem to own copies. A few have thumbed through it, depending on their particular interest. However, the original manuals was just overwhelming for a lot of people, and the people who read the original manuals typically didn't use the software as heavily as the people that didn't read the original manuals. There were all these kind of distinctions between who was reading the original manual and who was using the software and the overlap. So I wrote another document. In fact, I wrote a series of documents, including a description of two-dimensional vision, a description of the mathematics, and the third document I wrote was a document called Noble Ape Philosophic. I think I also wrote a Noble Ape Biologic as well. But Noble Ape Philosophic was a document that described, in part, some moulding of these ideas from Birch and Russell, but also my own thoughts that these two operators that I had seen within the Agar could be given two high-level names. One, desire, which represented the spatial spread of information, and the other, fear, which represented the time-undulating component of the information. And in terms of an emotive sense, desire worked well because it reinforced the surrounding structure, which is almost kind of like generating temporal reinforcing component. And fear worked well because it was extremely reactive, as the DT component was. So these two names stuck, although mapping the names from Noble Ape Philosophic into the cognitive simulation occurred in a kind of 96-97 time frame. When I was writing the Nature-Inspired Informatics chapter, I went back and tried to find original texts, and it was very difficult finding the linking components, but I do have some of the earlier discussion texts that I'd written and some early emails and these kind of things. I was able to cobble together a time frame with regards to those things. Now, the vision information, which really related to all sense data that came into the Noble Ape, but in this case specifically, it related in kind of a scanning horizon, caused problems with the initial Agar simulation. What I had originally was something that was very similar to a kind of cloud generator where the vision was along one axis, I think from memory the y-axis, and the X information just time spread through. And then there were actuators at the end that filtered the information that had come through the vision information. So there was a kind of time gap between when the vision information was pumped in versus when the actuators actually took movement from the initial vision information. And this algorithm didn't work particularly well. However, I did use it as a cloud generation algorithm for doing the sky in Noble Ape after the fact. There was a lot of recycling of code through the early Noble Ape development. What I realized was that there needed to be an additional dimension, that a two-dimensional cognitive simulation with a one-dimensional vision driver just wasn't working. So from that came the three-dimensional cognitive simulation, which you see to this day in Noble Ape. However, having established that, there still needed to be a lot of tuning. So if you look, well, sort of the kind of dip of Noble Ape development between about 97 and 99, I picked up again very heavily in 99 through to about 2000, 2001, particularly with regards to tuning the cognitive simulation. And if you appreciate, the cognitive simulation is based on the idea of desire, the idea of fear, and also this concept of the identity, which just represents the brain value, the raw brain value. And these three things are combined with weightings, which are based in the waking simulation purely on fear and desire, and in the sleeping simulation on basically half-weighted fear and desire plus a continuing component of identity. And this produces the Noble Ape dream state in some regard, which gives some refining of the cognitive simulation, the identity through sleep, but not quite the same way as through wake, obviously. Now, there are a number of interesting things that come out of this I write about in the Nature-Inspired Informatics text, specifically with regards to the weightings, because there are interesting underlying mathematical effects. You get and this was stated by Leo, and I mentioned it in the Nature-Inspired Informatics chapter as well, almost like glider effects as you get in Conway's life through the cognitive simulation when the noble ape is awake. And these things form almost, they're not standing state, but they're time evolving, but also maintaining properties that come through the size of the three-dimensional cube.
I don't understand a word you're saying.
Okay.
Because what you're telling is a historical and philosophical story.
Yes.
And like when things happened, and what was the thinking behind it. And of course, with artificial intelligence, there's been a lot of mistakes made by virtue of the fact that people have sort of used words that made things seem intelligent when they weren't. I think that's called the Eliza effect. And there was a book I read a long time ago by Doug Hofstadter called Fluid Analogies in Creative Thinking. And it's a really fascinating book because what he does is he and his graduate students, they've written a number of systems that work in domains that are so simple that they can't confuse you with this effect. They can't tell you that, this is... it's understanding what you're saying, because the way it works is on the basis of analogies. Analogies, and those are described in terms of just sequences of letters, doing like jumbles and things, jumbles of letters. So if we say, for example, AAB goes to AAC, then an analogy would be BBD goes to BBF. So that's a certain analogy, whether it's weaker or stronger. So it was all formulated in those terms with the specific purpose of avoiding the confusion of, I think that's called the Eliza effect, where people assume intelligence that's not necessarily there. And your description using fear and desire is, for me, something that I really can't appreciate in technical terms. So if there's a way to describe it without using fear and desire, like, for example, what is the substrate, what's the shape of it, and suppose we don't even use the words fear and desire, what kind of numbers are happening? I don't even know, to be honest, what the word Agar really refers to. So maybe in those terms a little more.
So Agar, in the sense, represents an energy value and, in the case of a single bacterial model, a population value.
Is it an acronym?
Agar, it's a biological thing. You put your finger or something in some agar and you give it a little warmth and you watch the bacteria grow.
How's it spelled? E-G-A-R or A-G-A-R?
A-G-A-R.
Okay, got it. Anyway, continue.
The initial agar simulation related to, as I said, energy and population. And it was just a weighting with regards to how populations grew and moved through this agar.
Okay, sort of like a Petri dish.
Yes, exactly. Exactly.
Okay. A two-dimensional matrix or something?
Exactly.
Okay, so it's Cartesian, square, two-dimensional.
Certainly. I, early on, particularly with regards to doing self-sustaining agar simulations, did end wraparound, so it's effectively toroidal.
Okay. And when you go into the three-dimensional version of it that you worked on later, that's also toroidal, but then in 3D?
Yes.
Okay.
In terms of fear and desire, if I is the identity matrix, desire is DIDS fundamentally. So it's the spatial spread of the identity values. And fear is DIDT fundamentally. It's the temporal change within a single cell over time.
So what does this eventually do? I mean, it's kind of strange because we're talking about a cognitive simulation which is simulated by a Petri dish. I mean, it doesn't seem like the Petri dish is going to, be intelligent all that quickly. So, what kind of intelligence is this? Is it something that could be easily represented by something else, or is it?
It's analogous in some regards to a neural network in terms of the effect of neighboring cells. However, unlike a neural network, it has a number of properties that neural networks don't have in terms of the cell communication, also in terms of the very basic nature of the time evolving components. if you understand the Agar analogy in terms of the population energy.
Okay, well, let me just ask you then this. You've got this Petri dish simulation. How does the sensory information arrive?
The sensory information is put into the Petri dish as if it were, in the Petri dish analogy, almost raising and lowering bacterial populations at a particular point, or in the case of the simulation, through a series of points.
Okay, so in other words, creatures are added or something, or population is raised. Okay. And
as time evolves, other points in the Agar are taken with regards to movement, for example.
Mm-hmm. And to what degree do you know that it works? Just observe the results, so you see the various movements, and there seems to be some behaviors that are probably recognizable.
Yes.
To what degree is this process scientific?
This is a very interesting philosophical question.
I don't know if it's a philosophical question. You can look at something and quite easily decide whether it's sort of operating on the basis of the scientific method, or with that kind of thing in mind. Does it actually represent something in the real world, or is there some expectation we should have that it should work?
Not at all.
Okay, so in other words, it's not a scientific phenomenon.
Well, if you look at, for example, the sinusoidal movement that are connected to genetic components in Darwin at Home, for example, would you say that was part of the scientific method, the mode of movement?
No, absolutely not. I mean, my work is much more artistic as well. So I'm just trying to get behind this. A certain number of aspects in the stuff that we're doing with artificial life is, I don't know, what would you say, arbitrary or something? It's just invented just to see what it looks like, without necessarily a hypothesis to be proved. In a way, what I've been doing is more like that. In fact, they asked me when I gave the first demonstration at the artificial intelligence conference. They approached me if I was interested in doing a PhD. I was going to be at the University of Maastricht. I had to think about it a lot, and I decided in the end that it wouldn't be something that I could spend the time on at this point in life. But what I did to make Darwin at Home could be obviously analyzed in a scientific way. I could have worked out ways to make graphs of different phenomena that were observed in the evolution and stuff, and I'm sure I could have eventually filled up a PhD with all sorts of observations that were really totally scientific in nature. It could have been done. For me, that dried it out somewhat too, which is part of the reason that I didn't go that route, because the way I saw it happening was sort of stop with development and try and write it all down and analyze it all. I felt sort of, mournful when I thought about stopping development, and I didn't really think that I could do both very well. Sometimes you just want to proceed rather than analyze. And in that sense, it's like having a paintbrush in your hand and continuing with your painting, which is also not scientific. So I was just trying to understand, your cognitive simulation in those terms. Is it, it's obviously something it's an example, it's a very good example of intelligent design. You just made it up.
Yeah, I think if you look at also the biological simulation, the underlying theme was taking completely different approaches to a problem which had failed to be solved or solved adequately with the methodology at the time. So in that regard, yes, I guess the cognitive simulation in Noble Ape is fundamentally a black box, which is really, it depends on what your definition of the scientific method is in some of these examples, though, because, if you look at string theory, for example, would you say that was part of the scientific method?
Yeah, of course. It's a theory that's attempting to arrive at predictions. If it doesn't, then it will eventually be discarded. I read an article a while ago that string theory in particular has been around for like 10 or 15 years longer than some people thought was justified, because it hasn't made enough predictions yet. So,
yes.
There's certain things that, even though they're a huge phenomena in the scientific community, they haven't really attained the status of being predictors. Our talk last week with Stefan was interesting as well, because his whole work was very, very much focused on the scientific approach. In other words, the simulation he was doing was intended to accomplish something, So there's an associated hypothesis. Presumably it'll be broken up into several parts and then described in gory detail in his PhD eventually when he's finished. But it's all about proving the analogy is sound and then seeing what the simulation does and trying to determine whether that has some implication with respect to biology. So it's constantly jumping back and forth between biology and simulation and saying, are we getting close? Are we getting close? Does this really represent something? And this is in your work, it doesn't sound like it played a really central role at all. And for my stuff as well, I mean, I've never really felt compelled to make the structures that run, and nowadays the structures that are growing, the tensegrity that are growing. I've never really felt the all-consuming urge to make it look like something in nature or to make it represent something in nature. I think of it in much more abstract terms.
But I mean, the interesting thing talking with Stefan is that there is some strange transition between the real world and the artificial life world in terms of the way they're, I don't know whether utopianizing is the correct term, but the way in which they are creating artificial life plants. I think the interesting part of the discussion talked about when he moved from a purely genetic model and a purely energy and what they were getting from the simulated voxel soil and the simulated voxel sky into some hybridization of these two ideas. Certainly what Stefan offered was not necessarily something that went back into the scientific method. There was an element of play which maybe we didn't talk about as much as we possibly should have. But I thought that was fascinating too, that what he's doing is not strictly part of the scientific method in terms of biological understanding. They're actually trying to find almost a new kind of simulation methodology that may then reach back into biology.
I would make a prediction that none of this will appear in his PhD thesis.
Yes, it's interesting because, I mean, he's a mathematician, as the whole group is. So they are not biologists fundamentally. They're looking for mathematical modeling methods, I would assume.
Yeah, but still, when it comes down to it, when they have to defend the whole process to the outside world and to peer review, they're going to have to really go for the theme of the degree to which it's analogous to real biology and the degree to which it lends itself to whatever, making predictions, or I guess it comes down to making predictions.
Because, I mean, my reading of what he was saying was that the virtual worlds, the future Second Life spores and World of Warcraft, in terms of the money that may be coming in through those avenues, would probably far outweigh anything that would be coming in through the biological sciences with regards to future funding of this kind of development. I mean, certainly my correspondence with Stefan's broader team and also my discussions with Bruce seem to indicate that the long-term goals for these kind of simulations was just as much to get them into, the next generation of MMOs as it was to pass back solid biological simulation data. Was that your reading too?
Yeah, well, likewise, none of this will get into the PhD. It might be a side issue, something that he's had thoughts about, but in the end, what he's going to have to present to his peers will be other stuff entirely. It's going to have to really say something about biology, I presume. It's not going to be something like, wow, this would be really cool for artificial life or for artificial worlds, virtual worlds. And I know as well as anybody that sort of artificial life would be real fun to kill.
Certainly, or real fun to learn from as well in some regard. No, it'll be interesting to see, and I mean, if Stefan's listening or if any of his team are listening, correspondence with regards to this would be wonderful too, to get some sense of whether the outcomes were to feed back into the biological sciences or to make the next wave of computer games, or maybe both even. I mean, they may not be mutually exclusive. But anyway, Gerald, in terms of the Noble Ape cognitive simulation, do you want me to continue? Do you have any more questions?
It's been useful to understand that it's a gelatinous substance derived from seaweed.
I think so.
That's what Agar, actually, that's the definition of Agar. No, it's interesting to understand that it's a Petri dish with some electrodes in it, and it seems to behave itself in a certain way, but you haven't really felt the need to make a direct analogy to anything in nature.
I send out some imploring through the nature-inspired informatics text that I think it merits some future investigation. And really, I don't know, I think it's something that I've certainly gotten 13 years' worth of amusement out of, and there have been a few tinkerers that have gotten additional amusement out of it. Another important point is Pedro Ferreira, who appeared on is open source good for artificial life Biota Conversations. He has tinkered with his own version of the cognitive simulation as well. So, I mean, there is the chance to tinker with agents and generate your own possible cognitive simulations from what's already in Noble Ape. One of the sections of Nature-Inspired Informatics text, I talked about dream interpretation in Noble Apes and the fact that you could still get movement out of the sleeping brain and then interpret what the apes were doing while or dreaming of doing while they were asleep. In terms of what we've been discussing with the philosophical stickiness of artificial life, it is really down to the individual practitioners to kind of continue to find sticky problems associated with their own particular developments. So we talked about Noble Ape. Let's talk about Darwin at home. In terms of the possibility of interactions and perhaps sexual or asexual reproduction, I go back to our chats of, I guess, a year or more ago now, quite frequently because I keep catching new bits of wisdom through them. Have you thought any more about strange landscapes, multiple Darwin at home creatures wandering over these landscapes together? Have you thought any more about that?
Yeah, having them interact as quote unquote animals amongst each other. I haven't thought about that to a great degree because I've been working on the tensegrity stuff, which is more analogous to growing plants. So that's why last week was interesting for me to talk to Stefan, because a lot of the aspects of his simulation might be useful for me as well. Already his idea of how to use voxels, for example, is an interesting idea if you want to build a whole energy accounting in a simple way into the system so that you can actually have simulated sunlight and shadow and this whole thing. So I'd be curious to see how he does that and learn from that in order to create sort of plant systems, which is what these tensegrities are moving towards.
The idea of evolving based on energy weightings from sunlight coming down on the Darwin at home creatures is absolutely fascinating. And in terms of giving a different kind of weighting, previously locomotion, but if they could have a kind of green sunlight component as well, you'd see evolution in a wide variety of directions you probably haven't seen up until now.
There's something I was thinking about the other day, and I was trying to make a distinction between artificial life and artificial intelligence, because there seems to be some overlap or some confusion between these two. And I was thinking artificial life is something which introduces malthus right away. In other words, as soon as something finds itself able to replicate, the next thing that will happen is that it will fill the entire universe. The pattern that appears and is able to replicate will spread endlessly, consuming resources until everything is full. And then presumably there's some way for it to make a mistake during replication. And every so often, and it doesn't have to be particularly often at all, but every so often some mistake happens to be advantageous. So then that advantageous translates into a new element in the population that once again spreads willy-nilly in all directions.
That's also based on the idea that resources are plentiful. And the fascinating thing is if resources are scarce...
Wait a second, they're plentiful in the beginning, but as soon as replication takes over and the entire universe, whatever that might be, is then occupied by replicas that are consuming resources, then this plentifulness disappears quickly and it becomes competition for scarce resources, depending on, of course, how you construct it. But the idea that you're making software somehow that has the potential of spreading to fill every possible resource and then start consuming it. And then what I'm thinking is, and what Stefan was talking about, is having a constant influx of free energy, which makes perfect sense. It's what happens on Earth. We have huge amounts of free energy coming in every day from the sun. That's an analogy you can hold on to. But of course, there's a certain amount you can do with that energy, and there will be competition in order to make use of it, or steal it from someone else by shadowing them or something like this. So this all eventually ties into the energy system, and this is what Stefan was talking about. Yeah, so it's not like resources are plentiful, at least not right after the very first sort of replication phase change, if you will. When something starts to replicate and occupy the entire resource base that's there, then it comes down to all the reserves that had built up, if that's the way the model is put. All the sunshine that's already fallen can be consumed, and then then you have to deal with only the stream that's coming in, and then there's going to be competition to get more of that stream. So that's back to scarcity. So that's what I was thinking of in terms of artificial life. So if I were to do this in Darwin at Home as it is, and I would love to, but time is very limited. And by the way, if there's any other developers interested in looking into this, I welcome some interaction, and I can probably help them quite a bit. And they've already got the rest of the simulation is already there, so it's a lot easier to make those steps. What I imagine right now to make Darwin at Home more interesting is something as simple as a sense that resembles a compass, and this compass will basically be something that points towards areas of more resources. So then you could create a landscape. You could create a whole bunch of individuals and let them operate on this landscape. It could be a little more complex. It could involve climbing hills or whatever. And the behavior of each of the Darwin at Home creatures would be somehow blindly based on the current value of a compass setting. So if it says northeast, then your behavior will change in order to turn northeast and go there and eat it. So something like that would allow for a simulation with large numbers of competing individuals that have survival of the fittest in a much more analogous way, an actual population where there's interaction. And then, what I'm always keeping in mind is the complexity that interaction in a real sense would involve. If I were to have to work out the spatial interactions of two Darwin at Home creatures fighting with each other, good Lord, that's a huge amount of work to get that exactly right. So, take a step of abstraction and you talk about proximity. And when two creatures are sufficiently nearby each other, they can compete in some sort of way. But they don't have to compete in physical terms with their individual, bodily elements, whacking at each other or whatever. That doesn't necessarily have to happen. It can be done in more abstract terms. So what I imagine is sort of, these little creatures scooting around the landscape on the basis of their compass and encountering each other and having sort of energy-based interactions on abstract terms to avoid all sorts of work with respect to what it might be like to actually lock horns physically. And this was very close to the analogy that Stefan was talking about. He did talk about virtual soil depletion and minerals coming up from the ground and combining with sunlight shining down. That was something that I had come up with in my own sort of imagining this about a week ago. Before I talked to Stefan, and I was surprised to hear that they also had actually used the idea of bringing together nutrients from below and sunlight from above, and only when they come together does it become what he called a biomass element. That was really nice to hear because it rhymed with what I was thinking.
Certainly. And through the history of Darwin at Home and even earlier when it was Fluidium, have there ever been multiple agents?
I set it up actually before I started evolving things. I set it up as a kind of a virtual world. So it was an applet where people were represented as dots that would connect up to these structures. Structures not all that different from the way the Darwin at Home creatures eventually turned out. These linked up structures of nodes and connections. And we had a virtual world sort of scenario, very, very simple, but we were able to sort of latch onto things and swing around like Spider-Man. There used to be a group of people who did that. And I built the whole networking aspect to it as well, so we were actually able to chat at the same time. It was very, very primitive, but it was really fun. And there was at one point we had an audio chat. There were about 5 of us at the same time swinging around a structure like this. It was really interesting.
That's very cool. Do you still have that code somewhere?
Good Lord, I don't think so. No.
Right, so it's not something you could return to and scrub up and then re-implement with regards to current code?
Not really, no. And, something like that is not all that hard to implement. Creating a chat world, it's something I could do right now, actually. And it's something that you've seen the applet, which I published a while ago, which is just the very, very first example. But it does have all the elements of a virtual world. You can scoot around, you can move left, move right, and up and down. You can basically ride a vehicle around a spatial universe. And what's happening right now is something very, just an initial experiment showing that tensegrity can sort of grow, and then eventually they grow too high and they fall over. And at the whole time you can scoot around this universe and feed them all over the place. And then the elements are coming in there. To add, the networking and the multi-user aspects and the chat to it is not all that difficult, and I would probably nowadays, hitchhike along with something like XMPP and a chat server, which already exists and is very efficient. Eventually, I'd like to get to a point, indeed, where you can share the same space in the virtual world and chat with each other. It's not very difficult. Chatting is no big deal, network-wise.
So you've segued perfectly into the topic for next week, and also some discussion with regards to the Grey Thumb Silicon Valley videos that I put up on the Grey Thumb blog last night. Watching Jeffrey's presentation in particular, and also thinking about GenePool specifically and moving it into open source, the wealth of knowledge that Jeffrey has, both in person and also in source code, really needs to be moved into an open source context. So, for example, you could start putting Darwin at Home creatures into his GenePool world and, utilize the mutual spaces. And if you generated a chat client or an interactive client, then GenePool could be used in that. And this really returns in some regard to the Evo grid as well. So the topic for next week relates to moving new projects or closed projects into open source. But I guess we're also talking about getting open source developers interested in developing artificial life projects. So hopefully we'll have folks coming from Floss Weekly with that in mind too. In terms of your own thinking, Gerald, is Darwin at Home really something that you see in isolation, or do you see it as being part of a broader, possibly collaborative project that could take in things like GenePool, could take in certain aspects of Noble Ape? Do you see it in that regard, or would you like to take elements of what you're doing with Darwin at Home and put them into something like GenePool or Breve or Noble Ape?
Actually, when it comes down to the Evo grid vision, I have to admit to being somewhat blasphemous, because I know it's impossible. It's impossible to say, this is a pipe dream. This is silly, because nobody wants to hear anything like that. So I won't say that, but I have to relate some of my skepticism with respect to the vision of having artificial life forms migrating from one place to another. I'd be happy to see how it develops.
But on a meta level, can you see that if, for example, you got a rich three-dimensional interactive Java environment that had chat, for example, that someone like Jeffrey would want to take GenePool and, if nothing more than just take your 3D chat client that had been used very well for Darwin at Home and adapt it to GenePool specifically? This is the idea of code adaptation as opposed to project interaction fundamentally. That what we need to do is create a broader kind of open source library of all our simulations that can in fact be used in a modular fashion. I talked in the Floss Weekly about the 2 historic Java developments of Noble Ape that I had implemented in 97, I think 2002, 2003. And I remember when you started talking about moving to spheres and planetary spheres. I passed you some Noble Ape landscape generation code for that as well. So, I mean, maybe the Evo grid is the wrong metaphor in terms of all simulators having the simulated entities communicating, but perhaps what it will do is actually share and refine our collective source code in some regard.
Well, describing in those terms, Tom, that's exactly, I mean, I can agree with that wholeheartedly. And I can, I can really appreciate the value of that, in the end with the idea of mutual inspiration or, ideas traveling from one simulation to another in terms, from one developer's mind to another. This is fine, but I haven't heard the Evo grid described in those terms. It's been more described in terms of, can a creature from this world migrate over to that world? And that's a different story, I think.
Certainly. But, I mean, I think what we are doing here is communicating at a number of different levels, and if we get to the stage where at least our source code is compatible or at least being mutually worked on, then we're a good way there in some regard, and we've done enough productive stuff to at least tick, 3 out of 4 of the particular Evo grid boxes. Now, with 1 minute remaining, I need to do a fast wrap-up, Gerald, but it's been wonderful talking with you this evening and touching base on both of our projects. For folks listening in, particularly folks who have joined us from Floss Weekly, the topic next week will be new and closed to open source, and also discussing what we've just finished talking about, the idea that artificial life developers and open source developers can get together and work on code and create new and exciting interfaces and potentially new and exciting artificial life projects for the future. Thank you very much for the chance to chat with you this evening, Gerald.
Okay, talk to you next time.